So we have our input panel right here for us to gain access to the system. It's a 4-digit password, but 6 push buttons are here. This is the reset button right there on top. So let's try 4126 and check. Enter. Access denied. The LED has to turn on green. So let's reset that input. Let's try 2156. Enter. Access still denied. Okay, let's reset that. Let's now try 21. Okay, let me just try 2153. Enter. Access still denied. It's an incorrect password. Let's reset that one. Okay, now let's see if we put the correct password, what happens. So 21, don't cram the other one. Then press enter. Then access granted. Access is granted. Hello guys, welcome back to Tronic Synergy. So today I'm going to show you how a password lock system circuit operates. So as you've seen in the intro, we have 6 push buttons, but the password only contains 4 digits. And another thing, the password has to be written in a specific way. As you've seen, the password is 22361. So this is a password, but if you write it in another way, if you start with 3612 or start with 63 then 12 or any other way, it's not going to light up because it's a state by state machine without using any microcontroller. So what we have here, these are NE555s connected in bistable mode. Right here on top we have NOT gates. I'm using them as buffer gates. I'm going to show you how I'm using them. Then right here we have the AND gate, which is checking if all conditions have been met and all state have been correctly put. And it's the one that's giving trigger to this NE555 to give an output when the password is correct and when you press enter. This is the enter key. So let's look at the circuit schematic. So this is a circuit schematic. It's pretty simple, but there are a lot of wiring involved that I've not drawn here. So right here we have the keypad or the input or the button interface where you put your password. We have 6 pins for you to put your password, and we are only putting four of them. So you have to choose correctly. Right here is the enter push button. From there we have the NE555s, which have been connected in a power chain series or in a chain sequence, where all the NE555 have been connected in bistable mode, meaning that we only trigger an NE555 to give an output. So when we trigger this first NE555, it's connected to VCC. So when you trigger it in the pin 2, which is the trigger pin, it gives an output. That output powers the next NE555. Then if you press the next correct one, it triggers the next one, which powers the next NE555. If you press the next correct key, it's going to trigger this third NE555, which is going to power the next, which is the last NE555. When you press the last key, it's going to trigger this, and all the outputs will be 1. So when all outputs have been are correct and have given 1, all of them enter this 5 input AND gate, but the password is 4 input. So the fifth key, the fifth input of the AND gate is the enter key. So this enter key checks if all these 4 conditions, these first 4 conditions, have been met. If they have been met, then once you press this push button for a brief moment, it's going to give a 1 output, 1. When it gives that 1, it's going to trigger this NE555 down here, which is connected in monostable mode. So means that once it's triggered, it's going to turn on its output for a specified period of time, which is decided by the capacitor you're using. If you're using a big capacitor, then it's going to stay for a longer time than using a small capacitor. So once it's triggered, it's going to give an output for a specified period of time, then turns off, meaning that it has granted you access, meaning that your password is correct. If let's say you start with either of the buttons, you can see if I start with this one in the initial state, if I start with this one, then go to this one, then this one, then this one, it's not going to turn on, because we have to put it in a specific pattern, because it's a chain. When I trigger this one, it powers this one. When I trigger it, it powers this one. When I trigger it, it powers this one. Then all of them are one. If I start with this one, it's not going to trigger because it doesn't have power, because its power comes from the previous NE555, and this one comes from the previous NE555, and this one is the first key to get. So even if I turn on this one, if I get this first key correctly, then I go all the way to here, then I go all the way to here, then here, then it's not going to turn on, because when I start here, it's going to trigger this one. Yes, this one is going to power this one, but you have pressed this one next, then this one, then this one, so the pattern is not going to turn on, because this one doesn't have power at that moment, because it's getting its power from the previous NE555. So as you can see, we have a specific pattern that it has to follow for it to turn on all these NE555s in order to give an output at the AND gate. And then when you get all the 4 inputs correctly, you press the enter key, which is going to check if all these are correct, and if all these are correct and they're 1, it's going to give one output for a brief moment to trigger this NE555, which is going to show you that you have been accessed, you have been granted access to the system. So here's the circuit. So the circuit, you can see here we have the push buttons, we have the enter key, the NE555 right here. These are the transistors connected to pin number 2 in order to trigger them. If you don't know how to connect by stable mode, I'm going to put a link below. I've done all modes in an NE555 for you to check. Right here on top, I've not drawn this. These are reset pin. I just added it recently because the circuit could not start all over again until I cut off the power supply. So rather than doing that, I just added a reset key, which is going to reset this first one. So once I reset the first one, it's going to reset all of them, because it's a chain connection. If I just reset these at the power pin, it's going to reset all of those NE555s. So as you see, so the password is this is the password 2361. If I put it 236 then 1, then I press enter, it turns on the NE555 for a brief moment, then turns off. This brief moment is decided by this capacitor. It's an 100 microfarad capacitor. If I use a much bigger capacitor, then it's going to stay longer when it's on. So when I want to rewrite everything, I press the reset, and when I try another configuration like that one, it's not going to turn on the LED, because that's the wrong password. I press the reset again, then I try another configuration. Let's try this one. It's not turning on because it's not the correct password. Not all the AND gate checks if all the conditions have been met, and they are not met, so it's not going to turn on the LED. Yeah, like that. And you can add a buzzer. So this is a buzzer, you can just add it if you want it. It's not a must, but you can add it. Okay, let me just say, okay, so let's put the correct password 2361, then enter, like that. It's not a must that you add the buzzer, but you can just add it just to make the circuit more fun. And that's how a password lock system is. So these two I've not explained this. So these two ICs are not gates, but I was to use a buffer gate. Because I don't have a buffer gate, I'm going to use NOT gate because I need a buffer. If you can see here, this is a chain connection, and once this gives an output to power this one, then the current is going to drop every single stage that we have the NE555. So right here in between we have the buffer gates, but I'm using a NOT gate to make the buffer gate. So the buffer gate is just to amplify that signal, because the signals are weak once they come out of the output of the NE555, because because this output is much lower than the power supply, and we need that kind of power supply to the input of the NE555 at its power input pin. So when you put buffers right here in the middle, it's going to amplify that signal for you to get the kind of power that you need to power your NE555s. So yeah, so that's basically what these two ICs are doing. And yeah, so this basically is how the circuit operates and how the circuit looks. So you can try this at home. Next time we are going to put a programmable password key in order, a system where you're going to program the next password that you want. If you want to change the password, then you're going to program it, and once someone comes and presses the push button, it has to be correct to that one which is programmed. Yeah, and it works. So thank you very much guys for watching. Please subscribe to Tronics Energy, and hope to see you next time. Goodbye.